Module number 4 is Software Designer. Design Principles and Concepts 4.1. Software design. Software design is a mechanism to transform user requirements into suitable form, which help the programmer in software coding and implementation. It deals with representing the client's requirements as described in the SRS software requirement specification document into a form that is easily implementable using programming language. So we have to present the client's requirements in as described in the SRS into a form that can be implementable using any programming language. The software design phase is the first step in SDLC, that is software design life cycle, which moves the concentration from problem domain to solution domain. So software design phase is the first step in the software design life cycle. So from the problem domain, it will move to the solution domain. In software design, we consider the system to be a set of components or modules which clearly define behaviors and boundaries. So it has clearly defined. We consider the system to be a set of modules or components with clearly defined behaviors or boundaries. So software design levels, there are two levels. External design, focus on deciding which modules are needed. There are specifications, relationships and interfaces among them. And second module is the internal design, focuses on planning and specifying the internal structure and processing details. Next, objectives of software design. Following are the purposes of software designer. So what are the objectives of software design? Correctness, completeness, efficiency, flexibility, consistency and maintainability. So a question can be asked, what are the objectives of software designer? So what are the objectives? Objectives are correctness, completeness, efficiency, flexibility, consistency and maintainability. So correctness. Software design should be correct as per requirements. So as per the customers or the client's requirement, the software design must be correct. Completeness. The design should have all components like the data structures, modules and external interfaces. So the design should be complete. It should have all modules. Efficiency. The resources should be efficiently used by the programmer. Flexibility, able to modify on changing needs. So if the customer has some changing needs in the future, then it should be flexible. It should be able to modify according to the changing needs. Consistency, there should not be any inconsistency in the designer. So the design should be consistent. There should be not any kind of inconsistency in the design. Maintainability, the design should be so simple that it can be easily maintainable by other designers. So if the designer, one software engineer has left the job and some other is going to replace, then it should be such that it is maintainable by the other designers as well. Software design principles. This can be a question. What are the various software design principles for 5 marks? So following are the software design principles. Problem partitioning, abstraction, modularity, top-down and bottom-up strategy. So first is problem partitioning. For small problems, we can handle the entire problem at once. But for a significant problem, divide the problem and conquer the problem. It means to divide the problem into smaller pieces so that each piece can be captured separately. So for a large problem, it is easier to solve the problem at first. For a small problem, it is easy to solve the whole entire problem at once. But if you have a significant problem, means a very large problem, then what you do first divide the problem and then conquer the problem. For software design, the goal is to divide the problem into manageable pieces. Benefits of problem partitioning. Software is easy to understand. Software becomes simple. Software is easy to test. Software is easy to modify. easy to maintain, software is easy to expand. These pieces cannot be entirely independent of each other as they together form the system. They have to cooperate and communicate to solve the problem. This communication adds complexity. Next is abstraction. The second principle is abstraction. An abstraction is a tool that enables a designer to consider a component at an abstract level without bothering about the internal details of implementation. Abstract level means the level which is there, which is an external level, without bothering about the internal details of implementation. Abstraction can be used for existing element as well as the component being designed. Here are the two common abstraction mechanisms: functional abstractions and data abstraction. Functional abstraction, a module is specified by the method it performs. The details of the algorithm to accomplish the function are not visible to the user of the function, the person who is using the particular function. In a programming language, there are inbuilt functions. The person who is using this inbuilt function, he is not bothered, or he will not be shown, it not be visible how this function was obtained to the user of the function. Functional abstraction forms the basis for function-oriented design approach. Data abstraction, details of data elements are not visible to the user of the data. Data abstraction forms the basis for object-oriented design approaches. Modular design. Modular design reduces the design complexity and results in easier and faster implementation by following parallel development of various parts of a system. We discuss a different section of modular design in detail in this section. Functional independence. Functional independence is achieved by developing functions that perform only one kind of task and do not excessively interact with other modules. Independence is important because it makes implementation more accessible and faster. The independent modules are easier to maintain, test, and reduce error propagation, and can be reduced in other programs as well. Thus, functional independence is a good feature which ensures software quality. It is measured using two criteria: cohesion and coupling. So, there are two criteria: cohesion and coupling, which measures the functional independence. Cohesion, it measures the relative functional strength of a module, and coupling, it measures the relative interdependence among modules. Second is information hiding. The fundamental of information hiding suggests that the module can be categorized by the design decisions that protect from the others. That is, in other words, module should be specified that data included within a module is inaccessible to other modules that do not need for such information. The use of information hiding as a design criteria for modular system provide the most significant benefits when modifications are required during testing and later during software maintenance. This is because as most data and procedures are hidden from other parts of the software, inadvertent errors introduced during modifications are less likely to propagate to different locations within the software. Next is strategy of design. This is your last principle. In strategy of design, a good system design strategy is to organize the program modules in such a method that are easy to develop and later to change. Structured design methods help developers to deal with the design and complexity of the programmer. If the design is structured, it follows a particular pattern, then it will be easier for the programmer to deal with the complexity and size of the programs. Analysts generate instruction for developers about how code should be processed and how pieces of code should fit together to form a program. To design a system, there are two possible approaches. You have two approaches: top-down approach and bottom-up approach. So you are starting from the top, going towards the bottom, that is going downward, that is top-down approach. Starting from the bottom, going upwards, that is bottom up approach. So this is bottom up and this is top down. Top down approach. This approach starts with the identification of the main components and then decomposing them into their more detailed subcomponents. So the main component first will be identified, that is, this is your main component which is present at level 1, and then decomposing them into their more detailed components. So this is their detailed components from level 2 and level 3. Bottom-up approach begins with the lower details and moves up towards the hierarchy. This approach is suitable in case of an existing system. So here you have the bottom component present at level 3, and then it will move towards the upwards, that is level 2 and level 1.